Welcome to the introduction to electrical engineering. Myself Manali, and today we will see the contents are Fleming's right hand rule, Fleming's left hand rule, principle of self and mutual induction and comparison of the same. First of all, we will see Fleming's right hand rule. Fleming's right hand rule is used to determine the direction of induced current when a conductor moves in a magnetic field. First of all, for this, to understanding this concept, first of all stretch your finger like thumb, forefinger and then middle finger of right hand so that they are mutually perpendicular to each other. Then observe that thumb denotes direction of motion of the conductor, forefinger denotes direction of magnetic field and middle finger denotes direction of induced current, and its application is generators. Then we will see Fleming's left hand rule. Fleming's left hand rule is used to determine the direction of force or motion of a current carrying conductor placed in a magnetic field. For this, stretch the thumb, forefinger and middle finger of your left hand so that they are mutually perpendicular to each other. Here forefinger denotes direction of magnetic field, middle finger denotes direction of current and thumb denotes direction of force or motion, and its application is electric motors. Here we will see the principle of self induction. First we will see self induction and then we will see mutual induction. Here you can see the definition of self induction. So it is defined as phenomenon in which a changing current in a coil induces an EMF in the same coil due to the change in its own magnetic flux. So according to Lenz's law, the induced EMF opposes the change in current produced in it. So formula for the self induction is E is equal to minus L di by dt, where E is equal to induced EMF, L is equal to self inductance and di by dt is equal to rate of change of current. For example, choke coils and inductors used in electric circuits. Here we will see the principle of mutual induction. So definition for the same is the phenomenon in which a changing current in one coil induces an EMF in a nearby coil due to the changing magnetic flux linking both coils. So the principle is based on like when the current in the primary coil changes, the magnetic flux changes and induces an EMF in the secondary coil. So formula for mutual induction is E is equal to minus M di by dt, where E is equal to induced EMF, M is equal to mutual inductance which is in Henry and di by dt is equal to rate of change of current in the primary coil. For example, transformers operate on the principle of mutual induction. So here we are going to see the difference between self and mutual induction. So EMF is induced in the same coil in case of self induction and EMF is induced in another coil in case of mutual induction. And self induction depends on self inductance, mutual induction depends on mutual inductance. Here in self induction, one coil is involved, in mutual induction two coils are involved. For example, in case of self induction you can consider example of inductor or choke coil, and in case of mutual induction you can consider example of transformer. Here we will see the summary. First we have seen Fleming's right hand rule and Fleming's left hand rule, and applications for the same are generators and motors respectively. Then we have seen principle of self and mutual induction. Then we have seen the comparison between self and mutual induction. Today we will stop here. Thank you.